So to get started on this, click the stop button at the top of the screen. To make an animated transition state, start by clicking at the top, Game Object, Create Empty. This will be, so you can see there's an opportunity to name it, the SN2, we'll just call it that, SN2 transition state. It's more than the transition state, it's the whole reaction. But this is a reasonable title. And on the right, and make the coordinates 0, 0, 0. So you can't see it, it's invisible, but it will be the placeholder for the entire transition state animation. Now, take the methyl bromide and drag it on top of the SN2 transition state. Do the same with the nucleophile. So now, if you click the gray triangle, you should see these are now children of this transition state game object. First, highlight the methyl bromide and give it the coordinates of 0, 0, 0. Then let's put the nucleophile in a reactive position. So highlight nucleophile, x equals 0, y equals -2, z equals 0. So now you can see this would be a good position to start the animation. Nucleophile is approaching from the bottom, leaving group will leave from the top. Okay, now click the SN2 transition state, and toward the bottom here, you need to make it animated. If you don't have animation or animator, click Window, Animation, and you can add these two windows. So click this Animation tab, and it should look like this. To begin animating SN2 transition state, create blah, 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 blah. You just say create. It's coming up with this file name new animation. So let's do SN2 transition state. This is an animation. Sorry, can't type. So you see it says type anim. That's an animation. This is a really powerful tool in Unity. Instead of putting it in the prefabs folder, try to put it in the assets animations folder. Okay, so if you open that, then save, and we are ready to go making this transition state animated. So let's do the nucleophile first. So we're going to animate all the atoms here. They all have to change their positions. But nucleophile is a good place to start. So if you highlight that, and here at the bottom with the animation tab open, click this red circle, looks like a target. It's the record button. And when you do that, this timeline should turn red. We'll make this animation occur over 50 frames, so I'm dragging this timeline marker to 50. And I'm saying, where do I want the nucleophile to be after 50 frames? And essentially, it's just going to move up a little bit. So here in the transform, I'll move it up to -1.5. Okay, if you want to see that motion, you can drag this timeline marker in the animation window and say, okay, there it is. All right. Now let's make it actually form a bond. So left of the nucleophile, click the gray triangle, there is a bond here. It's a hidden bond, but we want it to become a real bond between the nucleophile and the carbon. So to do that, once again, click the gray triangle and find bond stick. This is best done in scene view. Double click this bond stick and zoom out a little bit. I'm using the mouse wheel to zoom out a little bit. So you can see maybe there's this outline within the green sphere. That's the bond that's hidden to start with. So let's make it come out of the atom and bond to the carbon. Okay, so make sure your timeline is set on the 50 frame marker. Make sure you're in record mode, and this is red, and make sure your highlighted bond stick. Oop. And this, I think, should be 0.75 on the y-axis and 0.5 as far as the y scale. So now we should be able to look at this and say, okay, nucleophile approaches, and as it approaches, it makes a new bond. Okay, that's all we need to do for the nucleophile. Okay, I'm zooming out. I'm using my mouse wheel to do that, and I'm dragging it here. Okay, I'm going to close up nucleophile on the left with the gray triangle. Going to now look at the electrophile methyl bromide. Click the gray triangle to the left of methyl bromide. The top bond is the one to the leaving group. So the leaving group has to leave. When the nucleophile enters, leaving group goes away. So highlight leaving group. Once again, in the animation window, drag the time marker to 50. And we want this bromine to have left by that time. So it's real easy to do. Highlight leaving group, set the y coordinate to maybe be 3. Okay, so there it is. It popped off there. Maybe that's too much, maybe 2.5. Okay, so it will be leaving, but then it should take this bond with it. So here, bond stick will go inside this leaving group. So this is a little bit of guess and check here. So the y coordinate for the bond stick, let's make it 2.5 and make it a little bit smaller, 0.3. All right, so let's take a look at that now. Just see what does the leaving group look like. Zoop, it's like a little rocket ship. It's leaving. The bond is going away. It'll be invisible once it's inside the sphere radius. Looks pretty good to me. Okay. And then the last thing is just to make these hydrogens invert. It's easy to do. So once again, I'll close up the top bond rotatable on the left and focuses on this bond rotatable 1. For me, it's the one in the back. It might be a different one for you, doesn't matter. All we need to do is, in the animation window, drag the time marker to 50 frames and set the rotation of the Z component of the rotation, to 70.5. So you can see now if I drag the time marker in the animation window, that's all concerted. 70.5 is 180 minus 109.5. So that's why it's 70.5 measured from this top bond being the 0 coordinate for Z. Okay, same thing for bond rotatable 2. Highlight it, transform Z rotation 70.5. And bond rotatable 3, highlight it, transform Z rotation 70.5. Okay, so now if you did all that correctly, if you go through the timeline as I'm doing here in the animation window, this is the animated reaction through the transition state. Beautiful. Okay, that's it. It's done. Before we leave this, take off the record button. So click it, and we should go back to blue. You can click play in the animation window, and it will show you over and over again what you've animated. Click stop because it's a little seasick making. All right, so if we then go to game view, we should be able to see this, how it would look when a player's playing. And you press play, it should play. And there it is. It's too fast, I think, and it's continually looping. So we can change both of those. So click stop, highlight the SN2 transition state. At the bottom, click Animator. So this is this orange box is the animation that you just made. If you click it once, in the inspector on the right, you can see there's a box for speed. So probably 0.25 is a reasonable guess. So now if we play that, let's see if that's a more reasonable speed for education. And I think the answer is yes. Okay, so now I'm going to take away the looping. So I'll click stop, animator tab at the bottom for the SN2 transition state. And if you double click the orange box, then you have loop time. So I would just uncheck that, and it will only happen once now. Pressing play. And there it is, beautiful. Now press stop so we can move ahead. Now we can save this animated transition state as a prefab, but before you do that, expand it if it's not already done so. And you'll see this methyl bromide is blue and this nucleophile is blue. It'd be better if this is no longer attached to the methyl bromide prefab. So highlight methyl bromide, right click for me, brings up this menu. There's a choice for prefab, and there's a choice for unpack. So now you see this is no longer blue, it's black. Do the same for the nucleophile. Highlight it, right click, prefab, unpack. So this will make it so that you can change the methyl bromide prefab later and not mess up your transition state animated model. You can minimize all that and then click drag and drop. Drag the SN2 transition state down to the prefabs folder down at the bottom. And there it is. It's now there for you to use in an interactive reaction where we can steer the nucleophile and make the reaction happen.